Set A. Application, Maxima and Minima. Problem. A publisher wants to print a book whose pages are each to have an area of 96 inches squared. The margins are to be 1 inch each of 3 sides and 2 inch on the fourth side to allow room for binding. What dimensions will minimize its surface area? Let me now represent my drawing. This one is the page whose area is 96 inches squared. These 3 sides are the margins. The 3 of them has a 1 inch margin and the other one has a 2 inches margin to make room for binding. The width will be represented by X and the length will be represented by Y. I just add the 2 sides of the width to come up with X plus 2, and then I added the 2 sides of the length to have Y plus 3. Let's now solve for the Y. Let's just turn this equation to this and we get Y equals 96 over X. After that, let's solve for the area. So A is equals to X plus 2 times Y plus 3. And then we're just gonna substitute this to Y to get X plus 2 times 96 over X plus 3. After that, we're gonna use the FOIL method to have this equation. So X times 96 over X is equals to 96. Then X times 3 will have 3X. Then 2 times 96 over X will give us 192 over X. And then 2 times 3 will give us 6. So we have A is equals to 96 plus 3X plus 192 over X plus 6. Let's just combine like terms. So 96 plus 6 will give us 102. So now we have 102 plus 3x plus 192x raised to negative 1. After that, let's differentiate this equation. So 102 is constant, so that will be 0. The derivative of 3x will be 3. And the derivative of 192x raised to negative 1 is 192x raised to negative 2. So its derivative will be a prime is equals to 3 minus 192x raised to negative 2. Now we will equate this equation to 0. Now let's add positive 192x raised to negative 2 on both sides to cancel like terms. So now we will have the equation of 3 equals 192x raised to the negative 2. Let's multiply each side by x squared. So we will have 3x squared equals 192. After that, let's divide both sides by 3. So 3x squared divided by 3 will give us x squared. Then 192 divided by 3 will give us 64. Let us find the square root of 64 to find x. So x will be equal to 8. To test if the area is a minimum at x equals 8, we will use the second derivative test. If a double prime is greater than 0 at x equals 8, then the area is a minimum at x equals 8. A double prime is equals to 3 minus 192x raised to the negative 2. The derivative of 3 is 0 since it's constant. So let's just move negative 2 here. It will become positive 2, and then let's put 192 and then x raised to negative 3. So 2 times 192 will be 384. Then let's just substitute 8 to x and it will give us 384 over 8 raised to 3. So its answer will be 0.75. Since 0.75 is greater than 0, the area is a minimum at x equals 8. To find the dimensions, let's get the equations that we got earlier. We will just substitute 8 to x to have 8 plus 2 equals 10. To find y, let's get the equation that we solved earlier. So y is equals to 96 over x. So let's substitute 8 to x. Then we got 96 divide 8 is equals to 12. Now we can substitute 12 to y. So 12 plus 3 is equals to 15. And then our width will be 10 inches. And then our length will be 15 inches. And our dimensions will be 10 by 15.